Dear students, in the present class, we shall discuss about the carboxylic acids. Yes, what are these carboxylic acids? Carboxylic acids are the organic compounds containing the carboxyl group. Containing the carboxyl group. Yes, what is that carboxyl group? Carboxyl is derived from two functional groups. Carboxyl group is derived from two functional groups, or it is a combination of two functional groups. One is carbonyl plus hydroxyl. Carbonyl plus hydroxyl groups. Okay. Here, carboxylic group is represented like this COOH, and you know that carbonyl is CO, okay, and hydroxyl is OH. When you combine these two, what is the group? COOH is called as a carboxyl group. Carboxylic acids, see here you have to focus on the word acids. When an organic compound contains this COOH group, it will have some acidic property. The organic compound with COOH functional group will show the acidic property. That is why such compounds are called as carboxylic acids. Okay. And this is the sum of the carbonyl and hydroxyl groups. That is why sometimes we consider the carboxylic acids as carbonyl compounds. But along with that property, it also shows properties of OH group. Now, together it will form a new functional group. This is one functional group, it has its own properties. It is another functional group, it has its characteristic properties. When these are taken together, a new property will be exhibited by the compound. That compound is carboxylic acid. Okay, so it's very simple. Carboxylic group is having both the carbonyl and hydroxyl groups. Okay. Yes, and here we need to notice, recall the fatty acids. What are fatty acids? Fatty acids are higher members of aliphatic carboxylic acids. See, here also the name is itself fatty acids. Acid means it is containing the COOH functional group. Okay. But here these are aliphatic carboxylic acids. Aliphatic carboxylic acids containing carbon atoms from 12 to 18. From 12 to 18. Containing carbon atoms 12 to 18. C12 means number of carbons is 12. C18 means number of carbons is 8. Okay. What are fatty acids? These are higher members of the aliphatic carboxylic acids containing 12 to 18 carbon atoms. 12 to 18 carbon atoms. Okay. This is just the introduction about the carboxylic acids. Okay. Now, let us go for the nomenclature and isomerism of these carboxylic acids. Yes. Nomenclature and isomerism. Regarding isomerism, in the NCERT they have not mentioned, but it is extra point I am going to tell you. Okay. Nomenclature and isomerism. Here, in this case, isomerism, Generally, the first few compounds does not show the isomerism, like chain isomerism or position or functional group isomerism. As the number of carbon atoms in the chain increases, the alternate arrangements are possible. Okay, then it shows the isomerism. Okay, yes. In the nomenclature of any compound, in the organic compound, there will be two names. One is common name and the other one is IUPAC. And you know that the common names are usually given based on the sources from which it is extracted. Okay, common names are based on sources. Common names are given based on sources. Okay, and here this will have the suffix ic acid. In this case, the suffix will be ic acid. In the common system also, we generally observe ic acid as the suffix. Okay, and in the IUPAC, we need to follow set of rules. We have to choose prefix, word root and suffix. Okay, and these are not based on the sources, these are based on set of rules. Okay, here the suffix is oic acid. Suffix is oic acid. Here it is in the common name ic acid, here it is oic acid. Okay, let us go through this nomenclature with some examples. Okay, let's take down compound, then the common name, then the IUPAC name. Okay, the first member of the carboxylic acid is the one with one carbon atom only. Okay, see, when you take the aldehydes, the first member is with one carbon atom. When you go for ketones, it is having three carbon atoms. But when it comes to the carboxylic acid, the first member is having one carbon atom. And here you need to remember the general representation of the carboxylic acid is RCOOH. RCOOH. Here R may be an alkyl group or aryl group. R may be an alkyl group or aryl group. Okay. This is the first member of the carboxylic acid, and it is extracted from red ants. Okay. When a red ant bites, it will secrete a solution, and that will have some acidic property. Due to that only, the irritation will occur on the skin. That is a general example. Okay, in the Latin language, they call that juice or something, it is secreted by the ant, is called as formicus. Okay, that is why this is present in that ant bite. Okay, that is why it is called as formic acid. The common name of this compound is formic acid. And when it comes to the IUPAC name, we go through the number of carbon atoms, the substituent present and the functional group present. Here there is no substituent, only the functional group, that is COOH is the functional with one carbon atom. So one carbon atom methane, okay, replace that E with oic acid, it will become methanoic acid. One carbon containing hydrocarbon is methane. Here this E will be replaced with oic acid. Now it is called as methanoic acid. And in case of isomerism, okay, here the simple members of the families are not so able to exhibit the structural isomerism. So it cannot exhibit the chain isomerism because only one carbon atom is present, and it can also not exhibit any functional group isomerism. Okay, it cannot exhibit. Okay, it cannot exhibit. Okay, come to the second compound. homologous series of this is CH3COOH. See here you need to understand we can write this COOH in this form or in this form. Okay. Now what is this? This is occurring in the vinegar. Okay, and it is called as the acetic acid. For vinegar in the Latin language they call it as acetum. Okay, now it is called as acetic acid. Okay, now what is the IUPAC name of this compound? Two carbons are there, no? So therefore it is ethanoic acid. And it cannot exhibit any type of isomerism. Cannot exhibit. Okay. It cannot exhibit the position isomerism. It cannot exhibit the chain isomerism. Okay. It cannot exhibit the functional group isomerism also. Okay. Go for the next member. CH3, CH2, COOH. Okay. It is called as propionic acid. Propionic acid. Now, what is the IUPAC? 3 carbon atoms are there, no? So therefore, propane, propanoic acid. See, what is the difference here? Almost the same. Propio. Here we pronounce propionic acid. There, propanoic acid. That is the simple difference. Okay. And now, whether it exhibits the chain isomerism. No, it cannot exhibit the chain isomerism. It cannot exhibit the position isomerism also. And keep in mind that when you have only the carboxylic acid, no substitution. Okay, no substituent group or no other functional groups. We have only monocarboxylic acid. What are monocarboxylic acids? The carboxylic acid with only one COOH group are called as monocarboxylic acids. Monocarboxylic acids cannot exhibit the position isomerism because it is a terminal group. Yes. Then when you take the dicarboxylic acids, it will exhibit the position isomerism. Okay. And here this can also exhibit the functional group isomerism. What is functional group isomerism? Two or more compounds having same molecular formula but difference in the functional group. Now, it is a carboxylic acid. Carboxylic acids are functional group isomeric with the esters. Functional group isomeric with the esters. Okay. Now, what that ester will be, I will show you. Okay. It exhibits the functional group isomerism. It exhibits functional group isomerism. And what will be that isomer? Take that CH3 COO CH3. This is an ester. The propionic acid exhibits functional group isomerism with ester. That particular ester is like CH3 COO CH3. See, what is its general representation? RCOO R dash. RCOO R dash. Such type of compounds are called as esters. What is the general formula of the carboxylic acid? RCOOH. What is the difference between this compound, that is carboxylic acids and esters? Only the replacement of H with the alkyl or aryl group. R dash is there. Now we can call these carboxylic acids and esters as like brothers. How we have called the aldehydes and ketones? Aldehydes are RCHO. Okay, aldehydes are RCHO, or I can write like this. Okay, this is what aldehydes representation, and ketone representation is like this RCO R dash. What is the difference here? Only the replacement of hydrogen. Okay, always keep in mind that aldehydes and ketones are like brothers, shows similar types of properties, not exactly the same, it shows similar types of properties. Okay, come to the carboxylic acids. Its general representation is RCOOH, RCOOH, and esters representation is RCOOR dash, RCOOR dash. What is the difference? Again the hydrogen. That is why I am telling you the carboxylic acids and esters are like brothers. These will show similar properties but not the same. Okay. Yes, this is about IUPAC names of these three compounds. Now let us discuss with a few more compounds. The next compound is butyric acids, that is with 4 carbon atoms. CH3, CH2, CH2, COOH. Okay. Here, this compound is present in the butter. That is why it is called as a butyric acid. It is called as butyric acid. In the common system, it is called as butyric acid. In the IUPAC system, it is called as 4 carbon atoms. No? Corresponding hydrocarbon is butane. E is replaced with the oic acid. Therefore, it is called as butanoic acid. Therefore, it is called as butanoic acid. Okay. Come to the next compound. Okay. See here, whether it exhibits the isomerism, it exhibits chain isomerism. Let us see how. Take CH3, CH3, CHCOH. These two compounds are having same molecular formula, but difference in the number of carbon atoms in the parent chain. Here you have 3 carbon atoms, here you have 4 carbon atoms in the parent chain. Now, this type of isomerism is called as chain isomerism. Okay, this type of isomerism is called as chain isomerism. Okay. Now, what is the common name of this compound? This has a branch, no? So therefore we can call it as isobutyric acid. Isobutyric acid. Isobutyric acid. And IUPAC, the functional group carbon takes 1, 2, 3 positions. So where the substituent is present at the second carbon, so therefore it is called as 2-methyl propanoic acid. 2-methyl propanoic acid. 2-methyl propanoic acid. Propanoic acid and butanoic acid and 2-methyl propanoic acid are isomers. And what kind of isomers? Chain isomers. And here in the monocarboxylic acids, you may take that note. What is the note? Monocarboxylic acids. Monocarboxylic acids cannot show position isomerism. Cannot show position isomerism. Cannot show position isomerism. Okay. Because that COOH is terminal group. Because COOH is a terminal group. Because COOH. This group is called as carboxyl. Carboxyl. Okay. Because carboxyl group is terminal. Because carboxyl group is terminal. Okay. And keep in mind that the carboxylic acids are functional group isomeric with esters. Carboxylic acids show functional group isomerism. Functional group isomerism with esters. Not all the carboxylic acids are showing. Start from 3 carbon containing carboxylic acid, that is propanoic acid, it shows. Butanoic acid, it shows. Okay, yes. Next, we shall go for some aliphatic and aromatic monocarboxylic acids. Now, let us take aromatic. What is aromatic? When the COOH group is directly present on the benzene ring, is called as aromatic compound. Okay, an aromatic carboxylic acid. Take that. COOH is directly present on the benzene ring. It is called as benzoic acid. What is the name of the compound? Benzoic acid. Benzoic acid. Okay, it is the common name, and it is also preferred as IUPAC name. It is also preferred as IUPAC name. Okay, benzoic acid. IUPAC name is also benzoic acid. This is what preferred IUPAC name. Preferred IUPAC name. And when you go systematically, okay, what will be the name of this compound? Up to here we call benzene. Here one carbon is there. Benzene carboxylic acid. Like how we have called the benzaldehyde as a benzene carbaldehyde. The benzoic acid is called as benzene carboxylic acid. Okay. Benzene carboxylic acid. This is the systematic IUPAC name. This is the systematic IUPAC name. Okay. Now this is aromatic. What is this? This is aromatic. Keep in mind. Sometimes what happens, in the examinations, give an example for aromatic carboxylic acid. They will ask you to give an example for aromatic carboxylic acid. It's very simple. Take the benzene and keep COOH directly attached with that ring. Okay, that becomes aromatic. Okay, come to the next one. Okay, so this is one more compound. Now tell me whether it is aromatic or aliphatic. COOH group is present on the open chain. Is present on the open chain, not directly linked to benzene. Therefore, it is not aromatic. It is aliphatic. It is aliphatic. Okay, it is aliphatic carboxylic acid because the COOH is not directly present on the benzene. It is present in the open chain. Okay. Now, what is the name of this compound? Phenyl. This becomes a branch or substituent group. Okay. Phenyl. Then what is this? See, if it is CH3, CH3COOH is called as acetic acid. No. So the common name is phenyl acetic acid. Phenyl acetic acid. Then what is the IUPAC name? Carbon having functional group is 1, this is 2. Where the phenyl group is present? On the second carbon. Therefore, it is 2-phenyl ethanoic acid. 2-phenyl ethanoic acid. So, like this, you have to give the names of the carboxylic acids. Okay. Let us consider some cyclic carboxylic acids like this. So it is what a ring with 5 carbon atoms. 1, 2, 3, 4, 5. Okay. If I am going to take one methyl group here, okay. Now, out of these two, which one will be preferred? The functional group. Always, the functional group containing carbon will be taken as position 1. This is as 2. This is as 3. Okay. Now, it will become a substituent group, and we have to give prefix to this. Okay. methyl, where it is present at the third position. Okay, come to the common system. With respect to this carbon, this is alpha, beta, gamma. So gamma methyl cyclopentane carboxylic acids. Okay, gamma methyl cyclopentane carboxylic acid. Carboxylic acid. Yes. In the IUPAC system, okay, 3-methyl in the place of gamma we are putting just 3. Okay, remaining is same. 3-methyl cyclopentane, 3-methyl cyclopentane carboxylic acid. Carboxylic acid. Okay, like this we have to move. Okay, yes. Come to the next dicarboxylic acids. Okay, dicarboxylic acid means the organic compound with two COOH groups. With two COOH groups. Okay, let's consider some aliphatic dicarboxylic acids. Consider aliphatic dicarboxylic acids. Okay, let us consider some aliphatic dicarboxylic acids. Okay, the first one is COOH. COOH. It is possible. Okay, it is possible, and well-known compound also. It is called as oxalic acid. In the common system, it is called as oxalic acid. You remember these common names. These are very, very important also. Sometimes they will give you the common name and ask you to give the IUPAC name. They won't give you the structure also. Okay. Now, how many carbon atoms here? 2. Okay, and the COH are present at the terminals 1 and 2. So therefore, we have to call this as ethane. 2 COH are there, no? Therefore, dioic acid. Okay. What is the IUPAC name of oxalic acid? Ethane dioic acid. And you have to observe this E is retained. You have to retain the E of the hydrocarbon whenever you get di, tri, tetra, etc. If suppose it is a monocarboxylic acid, replace that E with oic acid. But when it comes to the di, tri, tetra, you have to retain that E. Okay. Now, the IUPAC name of oxalic acid is ethane dioic acid. Okay. Come to the next member. Or homologous series of this compound. Homologous series means differ by CH2 group. No, take that. Now it is malonic acid. It is called as malonic acid. In the common system, it is called as malonic acid. Now, what is the IUPAC name? Propane. 3 carbon atoms are there, no? Propane dioic acid. Okay. Propane dioic acid. We can write or else. What are the positions of these? This is 1, 2, 3. Or take this as 1, 2, 3. Okay. Where the dioic acids are present at the position 1 and 3. No? So we can give propane 1, 3 dioic acid. Here we can simply write propane dioic acid, or we can write propane 1, 3 dioic acid. It is a very systematic name when you mention the positions. Okay. Yes. Go for the next member. What is the name of this compound? It is called succinic acid. It is called as succinic acid. See how I have remembered the common names? Due to more number of practices, due to some clues. I will disclose that clue how to remember the aliphatic dicarboxylic acid easily. Okay? Yes. Later I will tell you. Now, what is the IUPAC name? 4 carbon atoms are there, no? So therefore, butane 1, 2, 3, 4. Butane 1, 4 dioic acid. Butane 1, 4 dioic acid. Okay. Come to the next homologous series. CH2, 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 COOH, and on this side one more COOH. Now, what is the common name of this compound? Glutaric acid. Glutaric acid. Okay. It is easy to remember also. I will disclose the clue later. What is the IUPAC name? 1, 2, 3, 4, 5. Okay. So pentane 1, 5 dioic acid. Or simply pentane dioic acid. No problem. Okay. Go for one more. The dicarboxylic acid. See here I can write easily like this. Here there are 3 CH2, no? I am going to make the 4 CH2 groups. Like this. Okay. This is called as condensed formula. This is called as condensed formula. Instead of writing 4 times the CH2, I am showing like this. Okay. Now what is the name of this compound? Adipic acid. This is very important one. It is used in manufacture of nylon 6,6. Okay, that you will come to know in the polymers chapter. The common name of this compound is adipic acid. Okay. Now, what is the IUPAC name? 4 times it is, no? Okay, 4 carbon atoms, 5, 6. So hexane 1, 6 dioic acid. Hexane 1, 6 dioic acid. Okay, these are the 5 common aliphatic dicarboxylic acids. How to remember the common names of this compound with a single word? O message. For message, we generally write MSG. For message, we generally use the code word MSG. MSG stands for message. Okay. There in past days, the text messages are very in daily use and famous also. Now WhatsApp replaced that usage of text message. Then that time, instead of typing MESSAGE, we were typing just MSG. MSG stands for message. You just pronounce this O message for number of times. You will easily remember that word. O stands for oxalic acid, M stands for malonic acid, S stands for succinic acid, G stands for glutaric acid, A stands for adipic acid. You practice more number of times, okay, then it will be easy to remember. In this order, O message, the first one is having 2 carbon atoms, the next is having 3 carbon atoms, then 4, then 5 carbon atoms, then 6 carbon atoms, like this. It's very easy to remember also. And IUPAC names are very easy to write. Okay. Yes, this is all about the aliphatic dicarboxylic acids. Let us consider a tricarboxylic acid, for example. Common name is not required here. What is the name of this compound? It is here at the terminals we have carboxylic acids, 3 COOH groups. That's why choose the options of functional group carbon atoms 1, 2, 3. Now the COOH groups are present on these positions 1, 2, 3. So take that propane, okay, 1, 2, 3 tricarboxylic acids. Like how we have discussed about the dicarboxylic acid. Now we take the tricarboxylic acid. This is propane 1, 2, 3 tricarboxylic acid. Tricarboxylic acid. See, here I am not going to call this as trioic acid. Why? I am calling this as tricarboxylic acid. Look at that prop, word group, 3 carbons are there, these 3 carbons. And COOH, this carbon is not included in numbering or it is not counted. That is why this COOH is called as carboxylic acid now. When it is counted, for example, in case of ethanoic acid, that carbon of COOH group is considered, numbered. Okay. Here it is not numbered and not considered. That is why COOH is called as carboxylic acid. Like that, we have 3 carboxylic acids, so therefore it is tricarboxylic acid. Now, what is the common name of, or what is the IUPAC name of this compound? Propane 1, 2, 3 tricarboxylic acid. Okay. Now, take a aromatic dicarboxylic acid. When COOH groups are directly present on the benzene ring, then it is called as aromatic. Okay. And what is the common name of this compound? Phthalic acid. P becomes silent here. Phthalic acid. And what is the IUPAC name? See, benzene, take this position as 1, this as 2, 1, 2, these are COOH groups, no? So dicarboxylic acid. Benzene 1, 2 dicarboxylic acid. Dicarboxylic acid. So in this way we have to give the common names and IUPAC. Writing the IUPAC name is very easy when you remember the IUPAC rules. Okay. Now let us consider the structure of carboxyl group. About the common names and IUPAC names is over. That is the nomenclature and isomerism of these carboxylic acids is over. Now let us switch on to the next topic, that is structure of carboxyl group. Like how we have discussed the structure of carbonyl group, it is carboxyl group. Okay. Yes, you have to carefully observe whether X is there or N is there. When here N is there, carbonyl it will be. Now it is X, means carboxyl. Okay. Take the carboxyl group. It will be having planar structure. Since that carbon is sp2 carbon, you know how to calculate the hybridization state of this carbon. When count this sigma bond 1, 2, out of 2 bonds, one will be the sigma, other one will be pi. When 3 sigma bonds are there, it is like S1P2. 1 plus 2 is 3. That 3 is nothing but 3 sigma bonds. Okay. Here, the hybridization state of this carbon is S1P2, or you can simply call it as sp2. Okay. Yes, it is based on the how I have calculated the hybridization state based on the number of sigma bonds. Okay. Now, due to the sp2 hybridization, the carboxyl group is having trigonal planar geometry with the bond angle 120 degree. Means P have three bonds, no? This one, this one, this one. There, the bond angle would be 120 degree. Okay. Now, let us go for the polarity of this group. You know that this group, this oxygen is most electronegative. It will pull electron towards itself. Okay. Now, initiates the resonance structures. So what happens? Polarity will be produced, okay, and you know that here there will be lone pair of electrons on this oxygen that will be present as it is, okay. Here also there are lone pair of electrons on this oxygen that will be present as it is, okay. Now, due to the shifting of these 5 electrons, it will get negative charge, it will get positive charge. Now, this carboxyl group is polar. Carboxyl group is polar in nature. And here, due to the presence of lone pair of electrons on this oxygen, undergoes delocalization. Like this. Why the shifting of lone pair of electrons takes place? To satisfy the tetravalence of this carbon. Now, this carbon is having 3 bonds, no? Okay, it is unstable. To make it stable, these lone pair of electrons are jumping over that. So, it will satisfy the valency of carbon atom. Okay, like this. Okay, now the oxygen is stable with its 2 lone pair of electrons. Now it has lost its 1 lone pair. 1 lone pair has become 1 pi bond. Okay, it has lost the electrons, no? So it will get the positive charge. Okay, it is all a polar molecule. Okay, and these are called as resonance structures. These are called as resonance structures of carboxyl group. Resonance structures of carboxyl group. Okay, and here when you consider the electrophilicity of this carbon, electrophilicity means the shortage of electrons, electron deficiency is satisfied due to the presence of the hydroxyl group. Due to the presence of the hydroxyl group. Hydroxyl group nullifies the electrophilicity of this carbon. Okay. That is why we say the electrophilicity of carbonyl carbon is high than the carboxyl carbon. Okay, it is very important point also. Note. Electrophilicity of carbonyl carbon N. See here, you have to observe the spellings also. Electrophilicity of carbonyl carbon. Electrophilicity of carbonyl carbon is higher than that of carboxyl carbon. Than that of carboxyl carbon. Means the electron deficiency of this carboxyl carbon is less when compared to the carbonyl carbon. Because in carbonyl carbon, no electron donating group or no group is showing the resonance effect. Which effect? It is called resonance effect. Okay. Because carboxyl, if they ask the reason, electrophilicity of carbonyl carbon is higher than that of carboxyl carbon, give reason. You can give this reason because the carbonyl carbon cannot show resonance effect. Because carbonyl carbon cannot undergo resonance or cannot show resonance effect. Cannot show resonance effect, or it is also called as mesomeric effect. While carboxyl carbon, while carboxyl carbon shows resonance or mesomeric effect. Okay, so this is all about the structure of carboxyl group, where carboxyl carbon is sp2 hybridized and its geometry is trigonal. Bond angle is 120 degree. It is a polar molecule, and the electrophilicity, that is electron deficiency of this carboxyl carbon, is less than that of carbonyl carbon, because it shows resonance effect and that cannot show. Okay, so this is all about the introduction, nomenclature, isomerism and structure of the carboxyl group.